This video is regarding the basic of differential equation, its solution, and the order of differential equation. So what is differential equation? So let's look at these two examples. The first one, I have 2y plus dy dx equals to 5x. So it is an equation because there is an equal. It is a differential equation because there is a dy dx. The second equation on the right, 6x times dy dx minus 3y is equals to 0. It is an equation because there is an equal. It is a differential equation because the dy dx is a differential, or you can call that derivative. Is there another way to write the dy dx? Yes, but I don't recommend that. So you can take a look at the next line. 2y plus y prime equals to 5x, and 6xy prime minus 3y equals to 0. So the dy dx is actually equals to y prime. I don't really like using y prime is because in the dy dx, I can see that you are taking the derivative of y with respect to x. So when you write dy dx, I can see that you are treating x as an independent variable. So that's why I don't really like y prime. But some textbooks prefer to use dy dx, some textbooks prefer to use y prime. Depending on the author, I prefer to use dy dx. When I was learning differential equation, I always use dy dx. And then what about solution? So y equals to f of x. So sometimes we use y, sometimes we use f of x. F of x, you can see the independent variable is x, y. You cannot see it. You have to check out the other side to see what the independent variable is. It's called a solution of a differential equation if the equation y equals to something and its derivative satisfy the equation. So look at the two equations I gave you. I have 2y, right? And then I have y prime, 2y plus y prime equals to 5x. So the solution is, you have to tell me what y equals to. So I give you a differential equation. 2y plus y prime equals to 5x. Your job is you have to find out what y equals to. So you get y, right? So y equals to some x, and then you can find out what y prime is, and then you plug it into the differential equation to see if that satisfied the differential equation. Satisfy means the left hand side equals to right hand side. And then regarding checking the solution of a differential equation, I will show you that in a minute. And then so now let's do this. The first equation is 3y prime plus 5y equals to negative e times raised to negative 2x power. And then my question is y equals to e raised to the negative 2x a solution? So that is what we have to find out. And then we have a differential equation, and then we have a y equals. So first of all, I can know that we can plug it in, the e raised to the negative 2x next to the 5, right? And then what about the y prime? So regarding the y prime, you have to find it. So what is y prime? Y prime is equals to, so this one, y prime is equals to the derivative of e to the anything is e to the anything. And then did I miss something? The answer is yes. So taking derivative, do you still remember chain rule? Chain rule is when the function is a composition function. So in this function, we have a composition function because there is a linear function, negative 2x inside the exponential function e. So therefore, when you take the derivative, you have to take the derivative of e, and you have to multiply the result by the derivative of the linear equation, which is negative 2x. So the derivative of negative 2x is negative 2, right? And then that's it. So now let's do the checking. So the first thing that we will have to do is we will have to plug it in. I will just write like this. So we have 3y prime, right? So 3y prime plus 5y, and then equals to negative e negative 2x. So the y prime goes where? The y prime, so this y prime goes here. So the y prime goes here, and then the y goes here, right? Okay, and then y prime, so we have negative 2e negative 2x, and then the y is equals to e to the negative 2x. So it looks like the next step is we will have to multiply the negative 3 and 2. So we have negative 6 e to the negative 2x plus phi e to the negative 2x equals to negative e to the negative 2x, and I can see that negative 6 plus phi is equals to negative 1, so I have negative e negative 2x equals to itself, so this is a check. Okay, so what about the one on the right? So the one on the right, I have y equals to phi y, and then y equals to c times e to the phi x. Is this a solution? So first of all, in differential equation, the big C stands for constant. Just constant is just a number without any variable, like phi, 6, 1/2, pi, e to the 6th power, so on and so forth. So first of all, let's find y prime. So y prime, okay, the color doesn't match. Okay, pick the wrong one. Right, y prime. So the constant, we can ignore that. The derivative of e to the anything is e to the anything, and then by chain rule, the derivative of phi x is equals to phi, so we have that, and then this is phi big C, and then e to the phi x, so we have y prime equals to phi times y, right? So the y prime, so this y prime goes here, and then the y, so this is a y prime, and then the y goes there. Okay, so phi big C e phi x, that's the y prime, and then the y is big C e to the phi x. Okay, so this one we have phi big C e to the phi x equals to phi times big C e to the phi x, so they are equal, then this is checked. So that means for these two differential equations, the solution I gave you is a solution of the differential equation. So that's how you check it. But you might be asking, hey, in these examples, you gave me the solution, but how do you find the solutions myself? Because when you were studying the first day, you learn solving an equation. Remember that day? Your teacher introduced what an equation is, and then the equation has an equal, right? And then has a variable. And then the teacher gave you a x equals to 6, and then you plug it in to see if that satisfies the equation. So this one, and then the next step is your teacher show you how to find the solution by doing all the algebra. So in this type of problem, how do you do the calculus, the derivative or integral to find the solution? Well, we are not going to discuss that in here, so we will discuss that in the following video. At this stage, I will just give you a solution, then I ask you to check it, and then later on, I will give you a differential equation and then show you how to find the solution of that differential equation. All right, we will do that next. Okay, the next vocabulary that I would like to introduce is the order of differential equation. So the order is determined by the highest order derivative in the equation. So when you look at an equation, you look for the highest order of derivative, and then I gave you 3 examples, the first, the second, and the third order. So as you can see, the first one, y prime is equals to 4y, so that is the first derivative, first order. Double prime, second derivative, then second order. And then the third order, you can write prime, so 3 primes, or you can just write a 3 in a parenthesis. The reason that we start using numbers like 3, 4, 5, and 6, because if you are doing the 6th derivative, you write 6 prime, but if you are doing the 10th derivative, you write 10 copies of prime. People are pretty lazy in counting the number of primes in there. So when you are doing the 6th or the 7th derivative, just write the number 7 in parentheses, so you know that, so people know that you took derivative 7 times to get there. Okay, so for the higher order differential equation, let's check, is this a solution? So the question is this a solution? So I have double prime, I have a y, so we have a y only, so we have to get to the double prime. So first, we have to find the first derivative. So what is the derivative of sine? Could you tell me that now? I heard cosine. Okay, so the derivative of sine is cosine. So c1 times cosine, and then the derivative of cosine, I heard people saying sine. I heard people saying negative sine. Okay, so which one is it? The derivative of cosine is negative sine. So we have c2 times negative cosine x. So negative, you get a past it, right? Let me just show you one extra line. So c1 cosine x plus c2 cosine x, and then the next one, double prime. So we have C1, the derivative of cosine is negative sine. So we have sine x, we put the negative sign in front of the C, and then the derivative, I said sine, right? I said negative sine, but I wrote cosine. Okay, my mistake. Sine. I said sine, right? Just go back to the video to make sure I said sine. Okay, sine. And then the derivative of sine is cosine. All right, so now let's do the plug-in. Okay, so we might need the whole line to do it, so I will just bring it down right here. So double prime negative C1 sine negative C1 sine x, and then plus C2 cosine x plus y. So y is C1 sine x minus C2 cosine x. Is that equals to 0? Okay, let's see. We have negative, and positive, and then we have a positive 1 minus 1. Yes, it is equals to 0. So this is check. This is check. We have 0 equals to 0. All right, so that's how you determine the order of differential equation, and then that's how you check the solution of a differential equation. In the next video, I will show you how to find the solutions by yourself. All right, so if you think my lecture is clear and helpful, give me a like, share the videos for me, subscribe to my channel if you're on your way out. Thank you for your support. See you all in the next one.